Hi everyone and welcome back to my channel. In this video, we'll be practicing SQL joins. From the last video, we talked about SQL joins. We talked about the different kinds of SQL joins, inner joins, outer joins, right outer join, left outer join, and all of the others. So this is the second video in our series of practice with me. We would have as many English queries as we can, and then we'll try to translate those English queries to SQL queries. Basically, we want to practice our SQL join skills. So if you have not seen the SQL join video, I encourage you to see it first, then come back to this practice video. So let's start with our first question. So the first question that we have, we want to find the title of books and the names of their authors, including books that do not have an author. So I already talked about how to get, we'll be using a book schema and the spy schema for this video. And I already talked about how to get them. And if, supposing this is the first video you're watching, if you look at the description, you'll find a link to download this data. So let's start. So if we want to find the list, the titles of books, of course, you start with a select and you go to, so this is your books schema. You expand your book schema. You want to go to the tables first, and we see that we have three tables in the book schema. In the book schema, we have three tables. We have the author table, we have the author book and publishers table. So we want to select the list, the titles of books. So I suppose the titles of books should be found under the book table. Yeah, so you have title. So you want to select title from, because this is not in a public schema, we would have to mention the name of the schema first, which is book, then the name of the table, books. And let's give it an alias B. So because we're giving it an alias, let's point it to this column. So I want to select b.title. That's the title from the books table, right? Because now we've called a books table in the book schema. We've called it B. That's an alias. So now we want to select the title from the books table. And the next thing we want, the question says to select the title of the books and the names of their authors. So now we want names of authors. So where do we find names of authors? That sounds like something that should be in the authors table. So we want to expand that, then expand columns. So here you see names, right? So I want to give the authors table an alias A. So I might as well just include it now. A.name. And now let me explain briefly. I want you to notice that this table, the question is asking for titles of books, names of authors. But look at the second clause. It says include books that do not have an author. So this means that even though we want books and their authors, right, we also want books that don't have authors. So that means that the title column will have more information than the author's name column, right? So basically, the titles column is the first column, and that's the column by our left-hand side. So this means this is going to be an outer join, first of all, because the title column would have more information than the author's name column. But also it's going to be a left outer join because the column by our left has more information. So this is going to be from this table, we do a left outer join, and we are joining book dot authors, and we give it an alias A. And as usual, when we have our join keyword, we have to join it on something. So we have join on, let's see. So authors has author ID. Books table has author ID too. So we can join on author ID. So we want to say B dots. We want to join on B dot author ID equals A dot ID. So that's it. So let's run this. So there you go. We have titles of books and the names of their authors. And in our case, it happens that all our books have authors. But if in our schema we had some books that did not have author names, those books will be listed down here, and for the name of authors we would have null value. I think it's a little bit vague. Let's let's change the title of each column. Let's call this as book title. So now this is another case of aliasing, right? You can rewrite the title of your columns in such a way that they make more sense when somebody looks at your table result. So yeah, let's run this again. So now you have book title. It's super clear now. For the book The Science of Tomorrow, the author would be Michael Johnson, right? So now let's look at the second statement. So here we want to find the title of books and the names of their authors, including books without an author and authors without books. Wow. So the first line is still correct because we're still looking for title of books and names of authors. But the little adjustment will come from the second clause. Include books without an author, which is what we have done here. We included books without an author and authors without book. So because this looks like left outer join and then right outer join, but if we were to take both of them together, that would just be a full outer join. So we want to change this to full. I hope this makes sense. So if our second clause only said include authors without books, so it means that our right column, author, would have more information than the book title, and this would be a right outer join. But since the information is asking for an interpretation that sounds like left outer join and right outer join, so this is a full outer join. And when we run this, yeah, so it happens that we have an author, right, that did not write a book, that has no book in our data for some reason, and that author is Caitlin Sanchez. No book is tied to her. So there we go. So if we had, let's say, include authors that have no book. So just like I explained, this would be a right outer join. Right outer join. And I expect to see Caitlin Sanchez as well. Let's see. Yeah, Caitlin Sanchez. Author has no book. So yeah, let's move ahead a little bit more. So let's go to our SPY database. So we want to find the team name. We want to find the team name for all teams with at least one agent who speaks English. I feel like this would be all teams because English. So maybe we could change that. But first, I want to see all the languages we have in our SPY data. So I think that should be in the language table. Let's see. We have about 11 tables. And we have the language table that has language name. So let's see. I want to select, let's say, language name from spy dot language. Yep. So we can go with French. Let's go with French. Let's go with French. Yeah. So we want to find the team name. So that sounds to me like select team name. So let's check for the team table. Where's that? Team. So this is a team table. We want to find what that column is called. It's called team name. So we want to select team name from, ignore this. We want to select team name from spy.team. Let's give it an alias T. So and let's point it to this column T dot. So we want to select team name for all teams with at least one agent who speaks French. Great. So we have a condition. We want the team name for all teams with at least one agent who speaks French. Okay, so right here we have, this would give us all the team names, but how do we fulfill this condition? So the next thing we want to do is we want to tie this to, let's see what the team rel table has. Where's the team rel table? Yeah. So we want to tie this to a table that has information on agent, because our team table just has team ID, team name, team meeting frequency. So the team ID can be joined with the team ID on the team and team rel table, and the team rel table would then connect team to agent, and that is what we want. So now that means we have a join going on here, an inner join. We can join the team to the team rel. I hope what I said did make sense. We have just, reiterating, we want to find the team name for all teams with at least one agent who speaks French. So a lot of things are going on with this query. We want team name, but we have a condition that includes agents and that includes the language of agents. So the first thing we want to do is, this is the main table, team name, right? But then we want to connect this team table to another table that has information about teams and information about agents, and that table is the team rel table. So we have joined it. This is an inner join, and usually we join on something. So join this on, let's give this an alias. Let's call it TR, team rel. So we want to join this on T, that's team, that's T dot team ID. Team ID equals TR dot team rel dot still team ID, right? So now that I've joined them on these two columns that have the same values, we now have agent ID within this combination. But still, we are looking for another table that connects agents to their languages, and that should be the language table and the language rel table. So let's find that. Where's that? Yeah, so we already have the language table open. This gives us language ID and language name, and we don't have that yet because these two combinations only give us agent ID, team name. So the first thing we want to connect, let's check the language rel. So I'm voicing out all of these things so that you understand how you think about problems and how you find connections within tables. So the language rel table has agent ID, and this can connect to the team rel, which also has agent ID. So that's what we are going to join next. So we have under join language rel, and as usual, I would give it an alias lr. Join language rel on and lr dot agent ID equals tr dot agent ID, and the lr has agent ID and language ID. So we want under table that explicitly calls out the language name, right? So, and that will be the language table, and we can join the language table to the language rel table using connecting it with the language ID column. So that means we have under join. So join spy dot language. Let's give that an alias L on, what do we have? Yeah, so we join that on language ID. So we have on L dot language ID, L dot language ID equals LR dot language ID as well. Language ID. So with these three connections, we have all the information that we want. We have a very large table now that has team name, we want team name, that has information about agent, we have that now, and that have information about the language name, we have that now. So we only have to specify the condition now. So we want our result to be team name where language name, right? Where L dot language name, that's this language name, language name is equals French. Yep, it's equals French. So this is what this query should look like. And when we run it, oh wow, these are all the teams that have at least one agent. We have 704 teams that have at least one agent that speaks French. If we wanted to, so just to make sure we don't have repetitions, you can use the distinct keyword. So let's run that again. Oh yeah, so now we have 44. That means, I guess as much, there was a lot of repetition in the data. So with the keyword distinct, you have unique team names where we have at least one agent who speaks French. And let's say the data was so long we're not able to count, and we cannot see the total number of rows. So we can as well just use the count keyword, and when we run this, we have 44. When we use the count keyword, it gives us a number, right? So the reason I'm introducing this count keyword in this context is because sometimes you might not be working on an interface like the pgadmin 4. You could be running on, let's say, the PSQL, another PSQL interface that doesn't expressly give you more information, right? So it's important if to know that you can use the count keyword to find out how many rows or how many records you have in your table. So this is what we have. So just for fun, Let's find out how many people speak Igbo. That's another language in our table. So let's run this. 44. Wow. Oh, that's nice. Oh, I didn't change that. Igbo. I was thought I did. Oh, 44 as well. Okay. So let's get on to the next question. Let's see. So I want to list each mission along with its security clearance description. So let's see. I want to list each mission. So let's find a table mission. Where's that? Language rel. Yeah, this is the mission table. Let's expand that a little bit. So in the mission table, we have mission ID, mission name, but no description. So security clearance description. Let's see. That could be in the security clearance table. So let's check out the column. Yes, we have description. So let's start. That would mean select, as always. We want to select each mission, list each mission. So we want mission name. So that would be spy.mission from spy.mission. Let's give this an alias M. So we want to say m.mission name, and along with its security clearance description. So we want to join. So this would be a join. We want to join security clearance. That's spy dot security. Do we have an underscore? No. Security clearance. Let's call this SC. So we have SC dot description, but we have to join this on something. So, and from creating this schema, I know that the access ID is a foreign key that references the security clearance ID. So we've joined, and this join is going to be on security clearance.id equals m.access ID. So when you run this, you have all that information. So we're listing each mission along with its security clearance description. It's always a good practice to use distinct, except you want a repetition in your results. So we see here that, for example, the operation Mojito, the security clearance needed for this operation would be access to information that involves position of significant public trust, but it's not classified. For Project Christmas, we want access to information that could cause exceptionally great damage to national security if disclosed. Wow. Okay. So this is what we have. Let's go to the next question. For the next question, we want to list the security clearance description for all missions. So, yep. And include security clearance that are not assigned any missions. So the first line 1 is still correct. Mission name, security clearance description. We want to list security clearance description for all missions. Line 1 is still correct. And include security clearances that are not assigned any missions. So we want to include this part that are not assigned animation. So this is our second column, right? This is by the right. So this is a right outer join. So instead of just saying join, we are going to say right outer join, right? So when we run this, let's see, we have 154. But this means that in our case, all missions have security clearance description, which I think is a good thing. But if it weren't so, we would have had some descriptions right here that did not have a mission. So, right, let's move on to the next questions. So for our next question, we want to find out the full names of agents who are associated with at least one affiliation. So I think yes, we have an affiliation table. So that's where we should be looking at. We want the full name of agents. So that sounds to me like we want to select the first name. Let's check our agent table. The full name of agents would be first name, middle name. Yes, we have first name, last. Oh, we don't have a middle name. So we have select first name, last name. I always like to point this to something. So I want to say from spy.agent, right? Spy.agent, and an alias is A. So I like to, I think it's good practice. Even if you think your columns are unique, it's always good practice to point them to their table. So that's why I use alias all the time. So I want to select, this is the full name, but the condition is we want those associated with at least one affiliation. So let's check affiliation table. Where's that? Okay, yeah. Look at it. Affiliation table has affiliation ID, affiliation name, description. But none of these are in the agent table, so we don't want that. So we want to check affiliation rel table. Let's see. So we have agent ID. So this can be joined, right? So we have, this would be a join. Give a little space join. And if you do remember from my last video, which I strongly recommend you watch before starting this practice, a join, as in the way I've written it right now on the screen, is exactly the same thing as inner join. Like if I had written inner, um, we did talk about this briefly in my last video, so please do check it out. So we have, we want to join this with affiliation rel. So we have spy.affiliation rel. And let's see, of course we'll have our alias as usual. Let's call this AR. So on a.agent ID, let's see, yes, agent ID equals affiliation rel dot agent ID as well. So let's see. So let's read the question again. We want full names, which is line 1, of agents who are associated with at least one affiliation. And the word at least means they have one affiliation or more, right? So anybody with one affiliation, up to 10 affiliations, 100 affiliations, whatever numbers of affiliation should be in this table. So this expression suffices. We have this. So when we run this, we have, so these are all the people. So you make it distinct as usual. If not, it's going to repeat it for all the number of times they have affiliations. For example, Gabriel Elon has, let's see, I know that he has 13 affiliations. That's what this means. His name was written out 13 times. He has 13 affiliations. And we don't want that repetition, so you use the distinct. So this means we have about 460 agents who are associated with at least one affiliation. All right, the next question, we want to list agents and their corresponding teams, if any, along with the team names. So this is the agent. with their corresponding team. So we also want team name. Let's go to the team table. Team table, where are you? Okay, yeah. So we have team name, right? So this is team name. So we want to add, I would give it an alias T. So I might as well just type it out. And here I would have team T. Right. And I would want to join that on, this is team ID, team name, meeting frequency, agents. Let's see. Oh, I have none of that on agents. So that means I would need another table in between agent and team. Wow. Okay. Let's find that table. Um let's check team rel. So the team rel has agent ID. That is great. So we're going to join that. So we want agents and their corresponding teams, if any. Um, so let's use teamrel. The alias will be tr on tr.agent ID. I know that this works. And we want to join again. Join spy.team this time. We want to alias that t on t.team name, I guess. Let's see. Teamrel has team ID. Team has team ID, so it's going to be team ID instead. Team ID equals teamrel dot team ID underscore team ID. So let's run this. So this is the list of agents and their corresponding teams along with their team names. So let's read this question again. So what I have done here, list all agents and their corresponding teams. But the bracket says if any. That means there's a possibility that we could have agents that do not have any team. So this means that we want all agents and their teams, if any. So we could have agents and their teams and agents that do not have any team. They are allowed in this table. So instead of having an inner join, what we actually need is a left outer join. It's a left join. We can call it left join, left outer join, whatever. But yeah, it's a left join. And here we also need a left join because we want to accommodate if any. So let's run this again. Okay. So we see we have 4,043 agents. I hope you did notice the change though. So before I changed it to a left join, we had about 4,034. But after I changed it to a left join, we had more records. So this goes to show that now we've included agents that did not also have team name. I'm just running this to show you that left join and left outer join all mean the same thing. So we have the same thing, 4,043. Great. Let's move on to the next question. This is becoming long. So let's see. We want to list all missions along with the agents assigned to each mission, even if some agents do not have assigned mission. So we want to list missions along with agents assigned to each mission, even if some agents do not have assigned missions. So this is, let's see, you have missions. I'm trying not to write this, but let's do this. I think I'll leave the next one for you to try. So we'd have select all missions. So that would be, I'm going to give it an alias M. So let's go with M the mission, just to be sure it's called mission name. Let's see. I'm looking for the mission table. Let's see. Yep. So yeah, it's called mission name. M the mission name from spy dot mission along with the agents assigned to each mission. So let's see. Yes, this has agent ID, so we can find those agents. So let's see. Mission name agents would be, I'm going to give it an alias A. So let's have first name A dot last name. Oh, I was supposed to write from. I wrote FPM, FRPM. From, okay. So what kind of join should this be? I think this is the point where we answer the question, alias M. So let's read the question again. We want all missions, which is our first column by the left, along with all agents assigned to each mission. That's the second column by the right, even if some agents do not have an assigned mission. So it means in as much as we want missions and their agents, we also want to see agents that do not have assigned missions. So this is a right outer join, right? So you have right outer join, right outer join. Now we have to join it on something. No, right outer join agent table. So we have a dot agents. Yes, agents on. We want to join this on a dot agent ID equals m dot let's see agent ID as well. So this is the query that we just wrote, and we have 864 records. But this is what I want you to realize, right? Looking at this syntax, it is correct. And this is why you need like a contextual knowledge of your schema while writing your SQL. So we want to list all missions along with the agents assigned to each mission. This query combines or joins the mission with the agent table. But this assumes that all agents are listed in the mission table, which could be wrong. It may not necessarily be the most accurate way to model this data. If, let's say, multiple agents can be assigned to the same, can be assigned to different missions, right? Many missions. And in this case, a rel table will be the most appropriate use for this kind of question. Just to make sure that you understand what I'm saying, this syntax is correct, but if you think about it logically, for this missions table mostly stores information about mission. Missions table is about missions, not primarily about agents. But we want a table that combines mission and that has all the information, including their missions if they have or if they do not have. So this, even though this syntax is correct, is not the most logical, would not be the most logically correct way to solve this problem. And that is because the missions table has information primarily about missions and not about agents. So this means that a lot of agents may not appear on the missions table. So to solve this problem more correctly, it's best to use a rel table. So let's get back to the rel table. So for the rel table, we have missions name, we have agents. Let's see. Let's check team rel. Let's see. So basically, we want a table that has information about mission and the agent, that has more comprehensive information about mission and agent. And let's see. So the team rel has agent ID and team ID. Let's go back to the missions table. The missions table has mission ID and team ID, right? So we can use this to join. So we have right outer join. Instead of spy.agents, let's use spy.teamrel, and the alias is tr, right? And this joins on tr.sameid equals mission dot team ID. And we also have another right outer join, right join. So the next right join will now be for the table, and it's going to join on agent ID dot teamrel. This, so let's run this. Spy dot. So when you run this, I want you to note the difference in the result. So now you have 23,000 agents. So this is a more comprehensive. This goes to show the point that I just made. Even though joining the missions table and the agents table is correct, right? But the missions table is about the mission. It's not designed to have information about all agents. Rather, it's designed to have information about all missions. So we want a table that has more comprehensive information about both the missions, connecting both missions and all agents, and that's the team rel. Right, let's look at the next question. I'm hoping that you'll be able to solve this question yourself. In this question, we want to retrieve the names of agents. So you want to do select first name from the agent table, last name from the agent table, and their security clearance level. Let's see. Where do we find that? Yeah, security clearance level. So that should be in the security clearance table. So this is it. Security clearance table. Security clearance level for all agents. But we need to join them because there's a disconnect between these columns and this column. So what table do you think you could use to join them? So let's see. Agent ID. So yeah, you'd find the table you'd need to join them. So we want a table that has security ID, and that has something about agent ID. I think we've come across a table like that. Let's see. Yeah, it would be one of these rel tables. So you just have to find it, and then would this be a right outer join or left outer join? It says even if some agents do not have a security clearance assigned, so it means we want more agents. So that's going to be a left outer join. So I think you should try that out on your own. I've given hints for that. So the fifth question, we want to find the languages spoken by agents along with their full names, include languages not currently spoken by any agent. So that means we want languages spoken by agent. So we want to select language, right? Full name of agent. That's from the agent table, first name, last name. And we want to include languages not currently spoken by any agent. So we want more languages. So that would be left outer join. So if you would try this, this is great. I think you should try this. So if you go to the language table, let me just share a little bit more light. You'd have language ID and language name. So we want the language name, right? Then we also want the names of the agents. So to include languages not spoken. So we want a table that connects languages and agents, and that should be the language rel table, right? Because language rel has agent ID, so you're going to connect language rel table to the agent table using agent ID columns. So when you connect this, you'd use a left join because we want more languages spoken by agents and not spoken by agents. So that's a left outer join. So I think you should try those two. Now let's look at this one. We want to list all agents along with any skills that they have, as well as agents who do not have any skills listed. So let's try this one together. As usual, you want to select all agents. So let's go with a dot first name because I'm going to give the agent name an alias. A dot first name this is A2. A dot last name from the agent table, that's spy dot agents A along with any skills that they have. So do we have a skills table? I think so, yeah. So this is a skills table. Okay, this is great. So let's see, we have skills, skill ID and skill name. So we want to get the skill name. So we have once s dot skill name. But the problem is nothing connects the skill table to the agent table. So I'm going to find, let's check the skill rel. This is a skill table, the skill rel table. Let's see. So for the skill rel table, yes, agent ID. So this works. So we want to do, what kind of join would this be? We want to list all agents along with the skills that they have as well as agents that do not have any skills listed. So that's a left join. So we have a left outer join. Left outer join scale rel spy dot scale rel. The alias will be SR, right? So we want to join this on SR dot agent ID equals A dot agent ID, and we want to now join the skill table. So that's still a left outer join. So we'll have left outer join the skills table, that's spy.skill on. So I like to give an alias s on s the skill ID. Skill ID equals the skill ID. So when you run this, you'd have distinct. Let's run this again. Yes. So we have all these agents and their skills, and I'm sure when we get to the last, we'd find agents that do not have some skill. Now let's go to the next question. We want to list all affiliations along with the associated agents. So this is just like the last question that we answered. Affiliations, the left column, the first column, along with the associated agents, the right column, include affiliations that do not have any agents associated with them. So just like we did, this is a left join. It's going to be a left join. So let's go to the next question. You can try that on your own. So it's more like an assignment. Try on your own, an assignment. So let's go to the next one. We want to get missions and agents involved in those missions and in ensuring to include all agents, even if they haven't been on a mission, and all mission, even if they do not have agents. So this sounds to me like both a left outer join and a right outer join, which is a full outer join, right? So we want to have missions and agents in those missions, including all agents, even if they do not have a mission, and all missions if they do not have an agent. So this sounds interesting. Let's do that. So let's start here. So we want to get missions and agents. So we have skill name. I don't want that. So I'm going to alias my mission table M. So I can just do this right now. Mission name. Then here I want a full outer join. I have to join them on something. So let's check. So where is the missions table? I have all these tables open. Okay. So the agents table have all of this information about the agent. So let's find the mission table. So this is the mission table. We have mission ID, agent ID. But this is just like that example where I explained that even though joining the mission ID to the agent ID in the agent's table would work, but the mission ID has information particularly about missions, not about all agents. So to get a more comprehensive information about agents, we need a table that has comprehensive information about agents connected to missions as well. So to get the missions and agents involved in these missions, ensuring to include. So if we were only dealing with this first clause, then joining the agent table to the missions table would do. But now we have a second clause that wants to include agents even if they don't have a mission. So agents that don't have a mission will never be found in the missions table. So we want to connect to create a more elaborate table that has all agents. So to find that, I remember we did find that in the team rel. Yes, so the team rel has agent ID and team ID, and the missions table has team ID as well. So we can join spy.teamrel, spy the timrel. Let's give that an alias called tr, and we want to join that on tr dot agent id. You can join that on agent id equals a dot agent id, and we also want to do another full outer join. So this is where we bring in the mission table now. So we have spy.mission m, and that is on m dot team id equals timrel dot team id. Okay, I think we've had so much for today. So this is what we have. So the next question, I did compile a lot of questions though. So the next question, we want to retrieve all teams and agents in each team, including teams without an agent and agent without teams. So this is a full outer join. It will be great if you've practiced this. And for the 10th one, you want to list security clearance levels for all agents, including agents without security clearance and clearance levels without agents. So this also is a full outer join. So we're going to be ending this video here. I think this video is really comprehensive. If you have any comments, let me know in the comment section. And if you haven't subscribed, please do subscribe. And I'll see you on the next video. Bye.